Okay, so for this particular problem, we are asked to find the most frequent vowels and consonants. And so we'll be given a string S. So looking at this particular input, we have to find the vowels, so get the vowels out of this particular string and also separate out the consonants and find the one with the maximum frequency, so meaning that the number of times that it appears. So you see, from this particular example, U occurs once and E occurs, which is a vowel, occurs twice, and so that's the maximum frequency. The maximum frequency is 2 here. And the consonants also, the maximum is 4 because S and C are both consonants, but the C only occurs 2 times and the S occurs once, and so the the maximum is 4. And so in total, maximum of the vowels is 2, maximum of the consonants is 4, and you join them together, making 6. And so that's what we're supposed to do, and we're going to tackle that. So I'll copy this and I'll head over and alright, so I'm going to copy this and head over. Let me begin with this right here. Alright, so find the most frequent vowels. Okay, now the first clue here is our letters are actually going to be from A to Z, and so we are constrained in this way, which is actually very good, because we are not dealing with any foreign characters here. Alright, and so what comes into mind is giving a string or an input such as let's say success here. Okay, so this is my input, which is SCSS here. What I'm going to do is that I'm going to find the frequency of occurrence of the individual letters. Okay, and the way I'm going to do that is use an integer array. So let me just put out the idea. So let me see, I'm just going to convert the character to 0 based index, the idea. Index. So what I mean by this is, supposing I have the string A, B, D, and let's say F. Okay, now I'll have a space of 26. Let's say this particular space or this particular integer array has a fixed size of 26. The reason why I'm using 26 is from letter A to letter Z. It's 26. Okay, it's 26 letters, and so my A will map to my first index, my B will map to my second index, my D will map to my 0, 1, 2, 3, 4, my fourth index. Okay, so anytime I see an A, I'm just going to make this place a 1. Anytime I see a B, I'm just going to make the second index a 1. Anytime so this one is for C, a C space. This one is for D, and anytime so this one would be a 1 over here. All right. So if it's empty, it means it's 0. Okay. So that's how it's going to be. So I'm going to map the letters for I'm going to map it as an index. Okay, and with that I'll be able to track the frequency. Okay, so let's say if I have a string and let's say I see an A, then I'm just going to update this one to 2. So at the end of the day, I'll have my space containing numbers, and those numbers represent the frequency of occurrence of the individual letters. Okay, all right. So it's just because characters in general are represented internally as Unicode values. Okay, so let's see something like this. Let me just go to G shell. Sorry. Okay, so when I say letter A, this is letter A, but internally it's represented as a Unicode ASCII. So when I do something like let me see, letter B minus this particular character minus A, I get a 1 because the Unicode value, so int of B, character B, sorry, int of B here is 98 and int of A here is 97. Okay, so once I get that, 98 minus 97 is 1, and so I'll be able to map the individual letters to the corresponding individual letters to their corresponding index. Okay, something like that. So let me just clear out of this, and okay, so that is the idea here. And so after that, I'm just going to iterate first of all, I just have my frequency array. Once I have my frequency array, I'm just going to iterate through the array. Okay, and if I encounter a vowel, so I just check a vowel. So let's say I can have my vowels E, I, O, U, and this one is very simple. This one has vowels have 5 letters, so there are 5 vowels from E to Z, and that would be better other than writing consonants and just checking for consonants. So I'll just check for a vowel. So if I encounter a vowel, I'll do something, and also if oh, what's happening? Okay, if consonant, I'll also do something. Okay, so let's use this as a case study. I'm just going to bring this here. Okay, I have it already here. Why did I go back? Okay, so given this particular input here, okay, so I'm actually going to create a space. So let's imagine I've already created a space for this particular string over here. Okay, and so I have my S, so the position for S would be somewhere, and to have an occurrence of 1, 2, 3, 4, 4, E will have an occurrence of 2, C will have an occurrence of 2. So that has been established, and so I'm just going to iterate through that particular space, and I just check a vowel. So I just check if, so let's say I encountered an S, because this one is going to be a number, so I would have to find a way of converting the number to a character. Okay, so just convert number to character. Okay, once I convert the number to a character, I'm just going to check if the character is a vowel or is yes, if it's a vowel. So let's say the character I converted or I saw was S. S is a consonant. Now if it's a consonant, what am I doing? What I'm going to do is that I would have a max consonant. Let me say a max C to keep track of the maximum consonant, and a max V to keep track of the maximum vowel. Okay, so what I do is to just get that particular value. Once I get that particular value, I just update the maximum consonant. So let me just say something like get value, then update consonant. Okay, and once I encounter a vowel, I just get the get value and also update the vowel. And now this is the max. So I have max C. Let me just use the max C and the max V. Update the max C. Okay, so after I've gone through everything, I'm supposed to return the sum of it. Okay, so you say return the sum of the two frequencies. So I'm just going to return the max C and the max V over here. Okay, so let's implement that in Java. So I'll head over to this point. Let me copy this from here. Okay, so what's our idea? First of all, we know our vowels. We make have my frequency array. Okay, so I'll just create my frequency array now. Alright, and just give it a space of 26 because we are being constrained here from our example earlier. Alright, A to Z, and A to Z, since we want to because of this idea, which we want to convert to 0 based index, and so we'll have from 0 to 25, which has 26 spaces. Okay, and so once we are done, what is our next step? Our next step is to we should have our vowels and also max. Okay, sorry, so let me have my max C and max V. Alright, then I'll have my vowels here. So let me just use a string vowels E, I, O, U. Okay, alright, then I'll have my frequency now. I'm just going to iterate through and convert numbers back to character. Okay, so now this is the space, but how do I have my frequency, my um, so this is just a space, this is just a space that I've created, but let's actually compute the frequency, or the occurrence, something like that. So the occurrence. Okay, so for just see in the string.to char array. Alright, so once I encounter a character, what I can do is my frequency of c minus a, alright, plus plus. So what I'm trying to do here is once I encounter, let me go to JShell and show you what I'm talking about. So once I encounter a character, let's say my character was s, let me use this, my character was x, I'm going to subtract it from a. And this is a classic trick because letters or characters have unique, they have Unicode, right? Basically they have Unicode, they are represented internally by Unicode or ASCII values. And so once I do s minus a, I'm just making my a as a reference to establish an index. So that's index 18. Okay, so this is actually going to pick from index 18, then increment it. Alright, and so once I encounter another s, I'm just going to pick the same thing and increment it, and that would be 2. Okay, so this particular line establishes that. So once I've been able to compute my frequency or my occurrence, I just iterate through and convert it back and check for vowels. So let's do that. Okay. Okay, so int I is equal to 0, I is less than 26, because I'm just going iterating through from 0 to 25, then I plus plus. Okay, so how do I convert? Because I need to convert the number back. How do I convert it back? So let's say I have a 2, right? If I want to convert this number back to if I want to convert this number back to a character, okay, so let's say this is the ASCII value, or this was my index. Let me go back here. Where is it? Yes, 0 based index. So this was my 0 based index. Let's say my 0 based index was 2. So how do I convert it back? I just add it to a. Once I add it to a, I just convert this particular result into a character. Alright, and that would be a C. So that's how I convert it back. And so I just move here and just write there. So my character is now, so everything that I wrote here, I can copy that and bring it here and change this one to my I. Okay, and so that's how I get the character back. Okay, so now that I have my character, I just check if it's a vowel. So if it's a vowel, I get the value and update the max v. If it's a consonant, I also get the value and update max v. Alright, so this is fairly straightforward. So once I have my character, I'm just going to check if it's in the vowel. So if so let me just say vowels dot yes, index of, so index of that particular chart that I'm having, if it's greater or equal to 0. Alright, because if it is if this one results in negative answer, meaning it is not in the vowels. Okay, that's how index of works. Okay, so if it is, then I'm just going to get and update the value. And so how do I update the value? This is the value, which is a max v. So max v now is equal to max dot the maximum of the current max v that I have, and the occurrence. So this is my frequency here, then what the occurrence of the chart that we've seen so far of the particular I. Okay, so once I have that, I also do the same thing for the consonant. So I'm just going to copy this whole thing here and change it to max c, which is my consonant. Alright, and so once I have that, I'll just have to return the sum of the max c and the max v. So that's what I do. I just return the max c plus max v. Alright, so sorry. Alright, so let's test this out. So I have I have a test method that's from the first one. Here we know that success, our output is supposed to be sys. So let's just do that. All right. So run. Okay. So return maxi plus maxv might not have been initialized. Okay. So let's go ahead back. Oh, okay. Maxi, then maxv. Is it this? Let's see. Oh, okay. Very good. All right. Then let's run that. Okay, so one test was successful. One successful test here. So I'm just going to go back and just copy this whole thing, and let's head to leetcode and let's paste this thing. Yeah, let's submit the code. Okay, so we have 812 out of 812 test cases passed. Okay, so what if, so the other thing is, what if, because we were given a constraint that the numbers or the letters are from A to Z, and so we could create a space of 25, and based on that we're able to allocate a space. Once we allocate a space, then the character becomes a zero-based indexing sort of approach. All right, but what if we are using other characters? Okay, so then our solution will need to change and stuff. We need to adjust our solution. So in that case, if we are using characters maybe outside BMP, then that's like other multilingual plane, then we need another approach, or we need a more general case. Okay, and that's where we use the hash map. So let me just flexible and general case. All right, so what's this flexible and general case? So this is the approach where we use a hash map. All right, and let me write a couple of things down. Okay, so when you're using an hashmap, the hashmap, the reason for the hashmap is to provide flexibility and make it a general case. All right. So in that case, we do not need to assume that the letters are from A to Z, and or they are tightly bound from A to Z, and it worked. So it worked for any character set. All right. And once the constraint changes, using the hashmap will actually work, right? Because we are using the hashmap to replace the frequency array that we did over here, which we bound. When you look at the solution, the frequency bound it to 26 set of characters. Okay. All right. So once you are using the hash map, it's the same thing. So let me just move over here, and what changes will be made. So instead of this, I would comment this out. Let me not comment this out. Let me just change it to a hash map. So let me just make it a map of my character. Okay, so that's what I was seeing over here, that this one actually makes it flexible. Okay, it works for any character set. So I'll just have a map of character and integer. So my key is going to be a character. Okay, then the character is coming from the string, and my integers are going to be the frequency of occurrence. Okay, then I'm just going to remove this, new hash map. Okay, and so once I have my hash map, I'm just going to compute the occurrence. Okay, how do I compute the occurrence? So first of all, I'll just change this. So I have for chassis, it's to s, or the input dot to char array, and I'm just going to remove this particular one from there because we're not using the array again. We are using a map, and so I'm just going to do frequency dot put. My key is actually going to be my C, and my value is actually going to be the occurrence of it. So first of all, I'm going to use the get or default. So frequency dot get or default. So I'm getting the C or default to a 0, and once I encounter that again, or if it's already inside, I'm just going to get the value and add 1 to it. And so this is actually going to build my frequency. Okay, so once I have my frequency, I'm just going to iterate through until this is the index way. I'm not going to use that. I'm just going to use the map.entry. Alright, so map.entry, and this one is actually going to be a character and an integer. I'm just going to name it entry in the frequency that I have, or in the frequency map dot entry set. Okay, so let me just zoom out a little bit. Okay, so once I have that, to get my chassis, I'm not going to do this particular thing. I'm just going to say entry dot get key to be able to get my character. And if I want my value, let me just see, it's going to be an integer, so the count, right, is going to be the entry dot get value. So to compare or to check if that particular char is in the val, I guess you have to maintain this because it's still checking if it's there. Alright, so if my val dot index of the c is greater than 0, which means it's a val, what I do is that I just update the max v. Also just, it's a consonant, so I just update the max c. So this has to change because I'm just comparing it to count now, and I'm comparing this one to a count now. Okay, and so let me run my code again. Alright, let me compile and let me just run, and one test case passed, so I can run. I can just copy this right here and run the solution again, and we are going to see that the test case pass as well. Okay, so you can see 812 out of 812 cases passed. Okay, alright, so we can implement the same kind of solution or the same approach in Python. So let's submit a solution for Python 3. Okay, so let me just copy this and just submit the same solution for Python 3. And just delete this. So I have my test case here for Python. You can see, so I can just see return 0, and I can just run my Python and see that it's failed. So let's write the solution for this. So it's the same approach. Max c is equal to 0. The max v is equal to 0. At the end of the day, I'm just going to return my max c. That's my max v. Alright, so to find the frequency, I'm just going to use counter and read get counter of my inputs. Sorry, I'm writing Python now. So okay, so I'm just going to go through for the character and the count in the frequency dot items. Okay, what I'm going to do is I'm just going to check. Okay, let me have my vowels here. So I'm going to use a set this time around so that my search becomes fast. A, E, I, O, and a U. Okay, so if the ch in my vowels, so I encounter a vowel, I'm just going to update the max c over here. So max c now is equal to the maximum of the max c and the count. Alright, so else, if it's a vowel, sorry, so max v is actually taking care of the vowel, and max c is actually taking care of the consonant. So max c and the count. Okay, alright, so I think this should be fine. Let me just run my Python. It's fast, so I'm just going to copy all this, go here and paste this, tab, not forgetting the self, so it's a class. I'm just going to submit this Python 3 solution. Alright, and so you can see 812 out of 812 test cases passed. Alright, see you